Synchronous Rotary Water Drainage and Gas Recovery Equipment Continuous Gas Lift process is based on Synchronous Rotary Water Drainage and Gas Recovery Equipment developed independently by Jiangsu Fengtai Fluid Machinery Technology Company Limited. The device is designed into container, which takes up less space and can be hoisted for ease of transportation. The equipment and associated frequency control cabinet, as well as natural gas generator, all have rain-proof and cool-proof functions to meet the field requirements. All the devices and pipelines are well arranged in the container. Main devices include Synchronous Rotary Multiphase Pump, frequency converter motor, inlet filter, inlet buffer pipe, exhaust buffer pipe, lubricant oil tank, lubricant oil filter, air cooler, pipelines and valves. The main process includes gas phase pressurization, gas liquid external transportation, lubricant oil circulation, safety rafting and bypass. As for the device, there's one inlet end and two outlet ends. 3 pipelines are used separately to connect the inlet end with well tubing, one of the outlet ends with well gathering network, and also the other one for gas reinjection with casing, which creates suction and gas lifting process. All the connections are done on the ground easily. Saturated gas produced by gas wells flows through intake filters into the inlet buffer pipe. After simple gas-liquid separation, one part of natural gas is injected into casing through 2-stage compression and the rest is transported through well gathering network. Lubricating oil storage tank is installed at the bottom of the device to provide oil under differential pressure in order to ensure proper lubrication, sealing and cooling function. The equipment realizes manual operation, automatic control and data collection through a frequency control cabinet, while connecting to digital communication system in the well site to achieve unmanned management. As we know, it is inevitable for unconventional gas wells to produce water. With continuous well production, flow potential drops gradually with decline of well energy. When the liquid cannot be effectively carried out of the well bore, the liquid will accumulate in the well bore, which is called gas well liquid loading. If no effective measures can be taken for fluid accumulation, continuous liquid loading will ultimately form higher fluid column, which causes back pressure on the formation, increasing BHFP, decreasing production pressure, as well as further decline in well production, which ultimately results in shortened well producing time and even off production. The characteristics of the gas well liquid loading include difficulty to discharge fluid, quick fluid accumulation, difficulty in stable production. Therefore, it is necessary to seek a kind of process with real consistency and continuity. There are 2 stages for continuous gas lifting process as following. Firstly, start-discharge process. Suction and gas lift processes are always operated simultaneously. Natural gas is pumped up by the equipment from tubing and re-injected into tubing casing annulus, which reduces tubing pressure and meanwhile increases the casing pressure. Perforations in horizontal throwers provide an effective channel to communicate the tubing and casing. Therefore, the re-injected high-pressure gas can push liquid in the annulus into the tubing, and the fluid level begins to drop until it touches the perforation so that high-pressure gas rushes into tubing and makes the density of well-bore fluid column decline rapidly. Gas bubbles are generated in a curved section, and during rising vertically, the bubbles are expanding. Using smelling capacity, liquid can be lifted onto the ground in the form of slug flow, like one segment of gas and one segment of fluid, to unload well-bore accumulation. With continuous re-injection of high-pressure gas, annulus liquid is pushed into tubing and lifted up onto the ground in a vertical segment. After the annulus fluid has been emptied, the liquid in horizontal tubing begins to be lifted out. As for the gas well with a one-way pecker, high-pressure gas enters directly into the horizontal segment through the pecker and then rushes into the tubing through the perforations and liners to unload well-bore liquid. Furthermore, For wells with a two-direction packer and no gas lift valve, the better solution is to make artificial perforation at 50 meters above the packers as the flow channel for analyst gas into the tubing. However, for the same well condition except with a segmented gas lift valve, the gas lift valve can be used as the flow channel for analyst gas into the tubing, which can effectively stop sand-blocking spools. Therefore, compared with traditional gas lift technologies, this kind of gas deliquification technology becomes an important method to improve reliability and effectiveness. Secondly, stepping to continuous stable production. After all the process above, liquid loading can be nearly emptied and the BHFP is dropping. So the producing pressure between BHFP and outside formation boundary increases. As a result, gas production rises naturally. Liquid density near wellbore decreases and liquidity gets improved. Continuous reinjection process enables the gas production to meet the critical liquid carrying capacity. The liquid can be carried out onto the ground continuously in the form of liquid droplet by high-speed gas current. So, theoretically, fluid accumulation should not appear in wells. With the processes implemented continuously, BHFP can be maintained within a reasonable pressure range, and meanwhile, horizontal liquid loading and liquidity near the wellbore get improved. Thus, well production is on the stage of good recycling period, which presents a continuous stable production. While compared with a key segmented gas lift for shale oil gas production in the United States, this kind of gas deliquification technology shows obvious technical and cost advantages. Moreover, it can be used for water-producing wells as well as flowing oil wells anytime during the whole producing period to bring great economic benefits.